this lecture, presented by www.free-academy.com, a user has submitted us the problem f of x equals 1 over the square root of x minus 1 over x, and has asked us to sketch this graph. This is another increasing, decreasing concavity problem, so we're going to treat it as such. We start out by rewriting f of x into something a little bit more convenient to do derivatives with. And we need to find the first derivative and the second derivative and set them equal to 0. Start off by finding the first derivative will be equal to negative 1/2 x to the negative 3/2, and this will be minus minus plus x to the negative 2. Then we can go on and do the second derivative right away. This will be negative 3/2 times negative 1/2, positive 3/4 x to the negative 5/2, and this will be minus 2x to the negative 3. We set them both equal to 0 to find our critical points and then do intervals and so on and so forth. Let's start out by solving the first derivative. This is, if we rewrite it, we get 2x to the negative 2 equals x to the negative 3/2. We'll square both sides to get 4x to the negative 4th equals x to the negative 3. And then we do just a little bit more algebra, and then we get x equals 4. So our critical point is going to be at x equals 4. Now that we have that, let's set up our intervals so that we can determine if this function is increasing or decreasing. First interval runs from negative infinity to positive 4, and from positive 4 to positive infinity. We're going to pick a number in each of these ranges, 1 and 5. And if we get a positive, this will mean that we have a positive derivative, which means our function is increasing. If we get a negative number, that means we have a decreasing function. So we'll find f prime of 1. I want to point out here that I'm not using 0 because we have, say, 0 to the negative 1/2 is 1 over the square root of 0, which is undefined. So we'll use 1, and I've already plugged this all into my calculator, so we'll skip straight to this. This is going to be equal to negative 1/2 plus 1, which is equal to positive 1/2. So we have positive here. The function is increasing from negative infinity to 4. By doing f prime of 5, we're going to get out the value negative 0.0047. Putting this into our calculator, this is a negative. The function is decreasing. So we increase from negative infinity to 4, and we decrease from 4 to positive infinity. Let's do the same thing on our second derivative to find where we have concavities, concave up and concave down. So we'll do the algebra to solve this. This will be 3/4 x to the negative 5/2 is equal to 2x to the negative 3. We'll square both sides again. We'll get 9/16 x to the negative 5th is equal to 4x to the negative 6. And this will give you that x is equal to 64 over 9. So we have an inflection point at 64/9. Let's erase some of this goo here and set up our table. Negative infinity to 64/9, and from 64/9 to positive infinity. Once again, we're not using zeros because our function is undefined at 0. So we'll use the value 1 and 8, because 64 divided by 9 is just a little bit bigger than 7. If we plug 1 in, we get 3/4 minus 2, which is of course equal to a negative number, and so this is concave down on this interval. And if we put in 8, we'll get 0.0041 minus 0.0039. This will be equal to a positive number, so we'll be increasing. I'll clear up a little bit more room again, and we'll just save our increase and decreasings. Draw some graph paper here. So we have 0. This is going to imply that this function is going to go to negative infinity as we go to 0 here. So we have the minus 1 over x. And we're going to increase until we get to x equals 1, and we're going to do so with a positive concavity. So I would say it would look something like this. Then we'll start decreasing until we get to about 7-ish, a little over 7, in which case we're going to switch concavities to concave down, but we'll continue decreasing. So if we were to magnify here, it would look something like this. And in fact, if we pull up our graph paper, that's really the same result that we get. And I also checked our first and second derivatives for accuracy. Zoom in a little bit, and we have a positive increase to about 7 where we get a concave down. It's not very easy to see, but it is definitely there.